The first treasure trove of data from NASA's Parker Solar Probe has been received. A Neptune-like exoplanet is baffling researchers, and the mission to Bennu, the asteroid, has been turning up some surprising findings. It's time for the second last Talkin' Science of the year.
With Dr. Brad Tucker and Matt Miller, this is Talkin' Science on Trek Zone.
Well, it's another Tuesday, which means it is Talkin' Science time. Dr. Brad Tucker is here. Dr. Brad, thank you very much for your time.
How's it going?
Really good. We're really close to Christmas now, aren't we?
It is creeping up. It's getting closer and closer. Scarily. It's that time of year of festivities and hotness. All those good things. It's also the time for the Geminid meteor shower this weekend.
Oh, yes.
Unfortunately, it's not going to be a very good one because the moons will have a full moon over the weekend, which means that the sky is very bright. So it kind of washes out the fainter meteor. So it's unfortunate because it could have been a good meteor shower, but with the full moon Thursday night, we're probably not going to see many. But if you do happen to, for whatever reason, I don't need to know, be out at 3 a.m. on Saturday or Sunday morning, look upwards and you might see a few shooting stars, or it might be for other reasons like the Christmas party, but let's not get into that.
Well, the lights from the sewage treatment plant.
That's right. Oh, yes.
I'm so glad you got that reference, so you got that joke.
I watch that movie pretty much every day the month of December.
Absolutely. It is brilliant. All right, well, let's dive into the headlines. Of course, you can find Brad at btucker22 on Twitter, Dr. Brad Tucker on Facebook. You can find me at Miramat86. Actually, getting those plugs in there, Brad, that's a New Year's resolution for me.
Yeah, good. Yeah, I'm going to do better at it as well, I understand.
Headlines of the week. NASA's Parker Solar Probe is beaming back the first insights from the very edge of the sun.
Yeah, so, the Solar Parker Probe is an ambitious mission to, as I say, boldly go where no probe has gone before. But it's true. It wants to go as up close as it possibly can to the sun, getting to essentially what we call the corona, the sun's photosphere, or the atmosphere of the sun, really. Because there's a lot of things we don't really know about the sun. A big thing is the surface of the sun is 6,000 degrees, but the corona, the outside, is 4 million degrees Celsius. So how is the outside way hotter than the surface? That is being a big question in science. And practically understanding the sources of what we call solar wind and space weather. The sun generates weather, wind, that impacts the Earth, not necessarily our normal weather systems, but things like radio communication. So understanding these processes is actually quite important for us here on Earth.
And the probe is the closest man-made object to get to the sun ever.
Yeah, so right now it's orbiting, or it got to about 24 million kilometers away, which doesn't sound that close. The Earth, though, is 150 million kilometers away, so much closer to the Earth. And it's slowly, still over the next 6 years, doing more and more orbits, getting to the point where it'll get 4 million kilometers from the surface, which is actually at the edge of the corona, the photosphere, the outside of the sun. So they say you'll be able to touch the sun, so to speak, directly, which is kind of a cool idea.
Jeez, and I thought it was hot here in Queensland.
Yeah, I was going to say, this is probably the only place hotter than Australia right now is the sun.
It's incredible. All right, well, let's keep going because something else is pretty close to another star, and it's a Neptune-like planet around a white dwarf.
So, yeah, a white dwarf is something our sun will be in billions and billions of years. And understanding how other white dwarfs exist and what happens around other white dwarfs is quite interesting because it tells us potentially the fate of our own solar system. Now, when our sun expands into a red giant, it will swallow up the inner planets. Sorry if that's news to you, but, that's reality. But, stupid Mars might survive. That's a different story. But the big question is, what happens to the gas giants? They're not going to be swallowed up, but the sun will puff out. And then when it kind of puffs its outer layers and remains as a white dwarf, it'll be a very small but still a very dense and have a lot of gravity. And so a new planet has been discovered, which is a Neptune-like planet orbiting around a white dwarf. But because this planet is now so close to the white dwarf, the gravity of the white dwarf is literally sucking off the atmosphere of the planet in essentially real time.
So it was ESO's Very Large Telescope that made this find.
Yeah, so ESO has a very sensitive instrument that is actually able to detect what we call radio velocities or wobbles in the light of a planet around another star. Now, this technique for finding planets it's more cumbersome. It takes a lot more telescope time than saying what we call the transit method, waiting for a planet to go in front of a star and see its dip. However, when you do get to use this technique, you actually see a lot more detail about the planet. So every time one of these planets is discovered via this technique, you get a lot more information because specifically you're able to probe and see the atmosphere of the planet and the star. And in this case, they actually realize that the planet is essentially leaking its atmosphere to the star, so the star is tracking it off of it. And we've known white dwarfs can do these things. In fact, what I study, type of supernova, white dwarfs do this to other stars all the time, and then eventually they explode. So it's interesting to see this now happening to a planet instead of another star.
You wouldn't want to go and you would be able to survive in a gas giant anyway, but you wouldn't want to go and visit this planet, would you, considering its atmosphere is hydrogen, oxygen, and sulfur?
Exactly, yeah. It's a pretty rough atmosphere. It's not very pleasant, and it's also the gravity of the star is so strong, they're literally just kind of getting pulled off of it. So it'd be kind of like if you launched a rocket, you go into space, and then the gravity of the star would just pull you toward the star. I don't know. Maybe that would work. And it's interesting because we always wonder what's going to happen to the gas giants in our own solar system after the sun expands. So maybe if the planets migrate, because we talked about this a couple of months ago, maybe planets do migrate inside their solar systems, that if the planets come closer, maybe this could be the ultimate fate of, say, Jupiter or even Saturn. Who knows?
Well, before we get there in our solar system's life cycle, I think that asteroids like Bennu are going to annihilate us anyway, and NASA's OSIRIS-REx mission has discovered that Bennu is doing something that is pretty hazardous to us. It could be possibly hazardous to us.
Yeah, so Bennu is an asteroid, and it's a type of asteroid that is more like a dirty snowball. It's more a loosely held clump rather than a giant space rock. And so understanding Bennu has been an interesting experiment. Why is Bennu more clumpy like this? And when OSIRIS-REx actually approached Bennu, what it actually found was giant jets of gas and rock shooting out of this asteroid. So it's kind of like fissures almost in the surface creaking out. And so it immediately did show that, yeah, this isn't necessarily a solid rock, but something loosely held together that can kind of crumble and break up.
So does that mean it's got its own little gravitational field around it?
Well, it would have a little bit of a gravitational field. That's right. That's definitely holding it together. And so these obviously raise questions about, well, what can we do these things? Now, OSIRIS-REx is going to eventually go to the surface and take a sample of it with this giant vacuum cleaner, essentially. So similar to Hayabusa, the Hayabusa mission. But, this obviously raises questions. If an asteroid like this is headed towards the Earth, can you deflect it? There are missions being built to try and deflect asteroids as we speak. But if you try and deflect it, and instead of it being a solid rock, it's quite loosely held together and it crumbles, well, what will that do? What are the impacts of this? Can you actually even do it, or will it just kind of fissure and you break off into two discrete chunks? So understanding these asteroids, not only to the hazards they pose on Earth, but for future exploration and potentially extraction of resources is a big deal.
Whether we're sending Bruce Willis up there.
That's right. I mean, we are all about shooting Bruce Willis at it and seeing if it fractures. But hey, look, we've already beat Bruce Willis. We detonated 10 kilograms of C4 in an asteroid on the asteroid Ryugu with Hayabusa earlier this year. So, Bruce Willis ain't got nothing on it.
Yeah, and it didn't cost us a space shuttle and a couple of lives.
Exactly. It's right. A lot more efficient, and it's landing back in Straya. So, it's a win-win-win.
Hey, getting back to Bennu, is classified as a near-Earth object. Does this mean it's heading our way, or is it just close to us?
So it's close. So anything within what we call that orbits within 1 AU, as we call it, so 150 million kilometers, which is the same distance the Earth is from the Sun. At any time, we classify as a near-Earth object. So even if it does these really weird elongated orbits but comes close and then out, we would classify that it's a near-Earth object, with the idea that it potentially can come near the Earth and obviously do things, which is why we track them. Again, why Bennu was specifically chosen. Can we know anything about these asteroids that come near the Earth, either in their formation or what we could do about it in the future?
Fantastic, Brad. Well, it is fun to talk science with you every week, and next week is our season finale for 2019, so I'm looking forward to that.
I cannot just physically believe that is reality. It is true. It will be our last episode of the year. Flabbergasted. People always ask when you do space, how do you put days into context? I don't grasp time, and astronomy does not help me with that idea and understanding the calendar year, so I don't get it.
Well, the thing I can't believe, and I'll have to do a count for next week, but we've now recorded probably close to 35 to 40 episodes this year. I don't know where the time's gone.
Yeah, exactly. It's quite amazing. It was just, it just felt like the other day when we were talking about Chang'e 4 landing on the far side of the moon and New Horizons going by Ultima Thule. Yeah, that was a year ago. But that's the cool thing. So much has happened in space, if you think about it, what we've covered this year, which is really exciting. And next year's going to be even more.
Fantastic, Brad. We'll catch you next week for the season final.
Take care.